You said we can pick up on something.
And I think it's number 3. I'll be setting up here. Amy for number 3. Alrighty, ladies and gentlemen, so today we got a very exciting day. So yesterday we finished off, we was talking about the electromagnetic spectrum, and I need to print you all off one. So, with this electromagnetic spectrum, we have discussed how all of it is either harmful or unharmful, where you find the difference at. So in this, where do you find the difference? Where's the switch?
From Mr. Pilkington's link group and Mr. Redden's
Going
link
from
group
not harmful to harmful.
Digital Learning Center.
I'm still waiting.
Wait, what'd you ask?
Where on the electromagnetic spectrum do we see the difference between something being harmful or not harmful?
The white box.
With the white box. Yeah, that's fine. Numbers don't even matter. But past visible light, when we go into ultraviolet, is it harmful or not harmful? Harmful. This, ladies and gentlemen, I now have a special gift for you. Take one, pass it around.
Christian Purdue, please go to Miss Crystal Thomas's room.
Not nearly enough in this one, but they'll make their way around. Giving you your own personal electromagnetic spectrum. It's the same thing as over there. Now in this, so that y'all know, you will still have my electromagnetic spectrum up there during the quiz to identify different sets of different things. For discussed, I will not be here on the 15th or the 18th. Which I'm pretty sure the 18th don't matter to this class. The 18th. It's 3 hour early dismissal. Y'all have a fantastic time. Alright, so on here. Oh no, you'll have it on Tuesday.
This Tuesday coming up?
He's not going to be here this
No,
Tuesday.
this Friday's a lab, so it'd be the following, not the Tuesday after that. Okay, hold on. So we should have it then. It's going to be Tuesday the 22nd. That's when we'll have the quiz. Alright, so in this, we've talked a lot about this electromagnetic spectrum, and now we're going to start using some information. We talked about 3 things. It's time to relate these 3 things together. With this, you're going to learn 2 constants. You must memorize the constant. My favorite one's the second one. You're going to see why. It's a super little simple way I came up with memorizing it. So here's your first formula, ladies and gentlemen. C equals lambda and nu. C equals lambda and nu. Look hot now here, paper.
Christian Purdue, come to the office. Christian Purdue.
Thank you, but she calls your name like this.
Alright, so in this, C is your constant. You've heard of this constant before. C stands for the speed of light.
Is that in purple?
Yes.
Okay.
What's that say?
Speed of light. Many people will look at you and say, oh, it's just 3.00 times 10 to the 8 meters per second. No, we care about accuracy and precision in this class. Ladies and gentlemen, 2.98 times 10 to the 8 meters per second.
It's the speed of light.
That is the speed of light.
That is fine.
Nothing is faster.
What's that? 10 to what?
10 to the 8th. Why don't you just move closer to where you can see things?
Then I can't talk.
Yeah, like that stops everybody. Okay. Then from here, these other two you've already seen. Lambda, which is wavelength. And nu, which is frequency. Important thing to stress here. Notice your constant. It has meters per second. If you're going to work all this, what do you think wavelength's going to have to be in?
Meters.
Meters. Dead giveaway. Now the second formula is my personal favorite. Because it's so much fun. E for energy equals the letter H, the American letter H, the letter H you learned in kindergarten and first grade, that H, nothing
Capital or lowercase?
lowercase, nothing different about it.
Why is it lowercase then?
Because it's constant. And that's how it's known. And nu.
Is that a U or
Nu. That's nu.
Can I get an E for effort on my quiz?
Wouldn't that technically be lower than an F?
You never know.
No,
Some
E
schools-
is
So,
A.
because it goes A, B, C,
I know, but
D.
like some schools, the A's equal A. Like
Oh,
Charleston.
whatever.
Seriously.
Well, we're not living in Charleston.
Well, we are in the line.
Alright, so here is your constant. It's the letter H. And this is by the Mad Daddy man himself. The man, the myth, the legend above all thing else. Anybody got a guess? Not Einstein. That's what everybody goes for.
I had to say it.
The greatest discovery, though, it is argued that this is his greatest discovery, was Einstein. This is Planck's constant.
Huh?
Planck.
That's what I thought.
It's literally plankton.
So
So
H
E is
equals,
for energy, right?
Yeah, I'm going to write it in a second.
so H equals Planck's.
It's Planck's constant. With this, now I know you're talking to people.
No, I seen it in anatomy.
Oh yeah, we did see that.
Okay. Planck's constant is my favorite, and this is why. Easy way to remember this. 6-point stitch.
Huh?
6-point stitch.
Oh.
5.
Experiment 626.
Oh. That's the one that eats the sandwiches is 2-5. Forgot about that.
Is.
Like Lilo and Stitch.
626.
That's his number.
That was his like experiment number. Oh.
Just get out.
Rip.
Get out.
Yeah, I don't.
Times 10, negative 34. And here's the units, and I'm going to stress this. Joule seconds. That's joule seconds. It's joules times seconds. Okay?
I want to throw this out there. I'm pretty sure a grade E would be higher than
Not my book. Alright. And from here, like I already told you, let's do it this way. E stands for energy. And U stands for frequency. I'll mark that right up. Please notice something in here. These two can be used interchangeably because they have something in common. What's in common?
And then you.
U. The frequency. Frequency is the same. So in this, you can be asked different little scenarios. So let's go with a hard problem. And then we'll start cracking it down easier, okay? So, what type of photon has an energy of 3.65 times 10 to the negative 19 joules? You probably have the question here. I already heard it. What is a photon? We'll get to defining a photon a lot more later on, but a photon is just a quanta of energy. Yeah. What's the question?
We were going to say, is it one of those couch beds?
What?
We were being sarcastic. I was going to ask if it was one of those couch beds.
But they're cousins.
Wow.
What is it, man? What are photons?
It's a quanta of energy. What do you call that? You're fine. Focus. So what type of photon has the energy of 3.65 times 10 to the negative 19 joules? Now this is the thing where I'm giving you this for a reason. You're going to have to use this. So in this you have a choice. This is what I'm going to tell you I'm going to go for. Every time I'm doing this, I'm going to go for wavelength. Because wavelength is a whole lot easier to read. Because if I can get it in meters, it's a whole lot easier for me to have to read and deal with. You can use frequency, but I like to use meters. So, in this, wavelength. So in this, start it up. You're going to use both equations in this case. Here's how you know whether you're going to use both equations or not. You're either given frequency or you're asked to find frequency. Are y'all okay?
No. This math's got me all kinds of
What's a
messed up.
menu?
What?
What's a menu?
Who will need the calculator?
New?
Like what's the number?
You have to calculate it
How?
using the formulas.
Anyone else?
But mu is in the formula. Mu.
Just let me work this, Chrissy. Alright, so in this is what you're going to do. Take the formula, you have something already set for it. So in this case, where are we starting?
Energy.
Starting with energy. Which one of our equations uses energy?
But wait.
E equals H nu.
Okay, so write it down. E equals Planck's constant times frequency. Okay, in this case, what am I looking for that's going to help me? What are they related together through? Nu. So if I can find frequency, nu, then we can work back to find wavelength. So in this, you got to rearrange the formula to find frequency is equal to energy divided by Planck's constant.
I'm so lost.
Why'd you do that?
Because I'm trying to get frequency by itself.
So whatever we want by itself, we put it on the equal sign?
But I just divided everything by Planck's constant. Okay, I'll go step by step. Sorry.
Thank you.
Our math skills are killing us. Alright, what's going on here? Multiplication. So to get frequency by itself, what do I have to do with Planck's constant? Divide by Planck's constant. Planck's constant cancels, leaves me with frequency equals energy divided by Planck's constant.
You went the opposite way that.
Yeah, you already got step by step a little bit. Not all that today.
I'm just.
We're a little tired.
Okay, so equals, now fill in 3.65 times 10 to the negative 19 joules divided by Planck's constant, 6-point stitch, joule seconds. This is where the units come into play. The joules cancel and it leaves me with seconds on the bottom, which is equal to inverse seconds, which is 1 over seconds, or seconds to the negative 1, and it's also known as hertz. So in this, we punch that in a calculator. You should, by this point, be able to punch this stuff in a calculator, hopefully. 3.65 10 divided by hopefully you come up with 5.5086 times 10 to the 14 hertz. Bless you. I love you. I'm saying this right now because people in this room missed points on the quiz because you couldn't punch something in the calculator right. You should take a calculator right now and punch this in. And if you can't figure out how to punch it in right now, that's where you need to ask.
Okay, I need your help.
Yes.
Why do you put it in?
Because this is equal to an inverse seconds, which is equal to seconds to negative 1, or just negative, which is equal to hertz.
So if it's J, then it's H, whatever, HZ. Right? Like if we're
I
in
think your exponent
joules,
is wrong.
Yeah, I did too.
if we're in
I
joules,
got negative 54, negative 10 to the
See, I'm
negative
still getting
54.
zero.
I got 14.
I got 14.
I got that
I know,
up there.
But I got
You see calculator.
I have a question. Do we have to, not if we see.
I put it in right because I read it like 6 times. Let's see if I did.
I can get 14.
I got 14.
I got 14.
Put multiplication. As soon as you put the multiplication, the calculator was reading it as you're multiplying it.
We don't have, we don't put it for the negative, do we?
Negative exponents, you absolutely do.
Come here, I'm so confused what I'm doing.
What do you mean you put all that? Like on the front?
She put multiplication in there. You shouldn't do times t. That's the wrong t.
Does he mean like you have to do the
Look,
3.6?
parentheses.
You put in
3. Second, comma. See the difference between these? Negative 19 in parentheses. Then from here, we're dividing. So divide by 6.626 seconds
What do you do with that?
That was in the summer, right?
That is not AJ.
Right?
I think
No,
that's
that's
just
Yeah, you never put it. Always times 10.
Oh. Hold on, let me see if I got it.
I'm gonna try
Anybody
this
else?
because I got a new app that I bought, and it's supposed to be the same thing as the
Why is it
calculator. Try and see if it works.
Do the problems get harder than these?
No, because we're not done yet. This isn't the end. This is the first step. Yes.
How the second
Do what?
How are the second people?
It's inverse seconds. It's a unit that we came up with. It's 1 over, like if you do this, okay.
Why did he put H?
This is what I do in physics all the time. Kids don't understand where the units are coming from. You have joules over joules times seconds. What cancels? Joules cancel. But that doesn't make this seconds. That is wrong.
Wow.
Because seconds is on the bottom. It still has to stay on the bottom. So there's a number 1 on top. It's 1 over seconds. Which is also a mathematical expression. You can write it like that. Seconds to the negative. And in science, we look at this as hertz.
We'll just put S to the negative.
You can.
So with the S, you have to use the
No, you put times and E.
Okay, even
You
if
can't mix them.
even if I don't, I still get negative. I put that and it gave me negative equal to.
That's why I don't like using it. Because then if you're going to do this,
Yeah, see, I got that.
I got
You have to do 3.5.
you're not in parentheses. I say always put them in parentheses because of that right there.
I did.
Your calculator is stupid.
See, I didn't
I
put
still got 14.
I didn't put a parentheses
But
right there.
that's the thing. Your calculator's reading what you put in separately than what she's putting. You put something totally different. It's all about your calculator's stupid. Your calculator's not going to sit there, and it's not smart. It doesn't look and say, oh, well, they're wanting to do this problem that's up on the board. Let me make sure you calculate that right for them. They're going to look and say, okay, well, they set that up. I think they're wanting to do this and then times that by negative 34. I think. Oh, okay. It pops out negative 55.
So this time I just got
54, whatever. That's why it matters.
I put like instead, I put times 10 and then E, so that matches me up.
Don't put the times 10 in the E. Alright, then from here, you're not done because you have found frequency. Now, if you want to give this a shot off that frequency, be my guest.
Wait, what?
It's nice.
Could be in
If you want to give this a shot from frequency, go ahead.
I'm gonna give this a shot.
But this is the thing. I'm going to say it's non-infrared. Because that's times 10. That's 1 times 10 to the 14th right there that you're looking right in infrared. Between times 10 to the 14 and times 10 to the 15, you have infrared, visible, or ultraviolet. And you're falling right in the middle. So I'm going to tell you, from me looking at this, I think we're going to end up with some visible light.
I'm so confused.
This is what you're doing. You're trying to identify what type of ray this is.
I need any AM trade school that needs to order.
What type of electromagnetic radiation is it? Radio, microwave, infrared, visible, ultraviolet, X-rays, gamma rays. And so it's not radio. Close radio.
How do you know?
Because I'm looking at this number right here. I have the frequency. So over here on your not periodic table, on your
Watermelon.
Bless you.
pineapples,
Pineapple.
strawberry. Ah,
Are you okay on that one?
Alright.
I hurt a little, but I'm okay. Okay, on here, this is what I'm saying. You're falling in this area. If you're watching the video, close your eyes. You're falling somewhere between here and here.
5 and 15.
Because you're 10 to the 14th. This is 1 times 10 to the 14th. And this is 1 times 10 to the 15th. I can still fall in there. Somewhere back behind here. Anywhere back behind here is still times 10 to the 14th. Now this is the thing. When you're looking at that problem you have up there, that 5.5086 times 10 to the 14th hertz, that's telling me I'm falling somewhere in here. And since that's about halfway, we're looking halfway in here somewhere. So you're looking at visible light. So now you're breaking from visible light. And this is what I'm going to ask you to do. I want to know the color.
Green.
No.
It's right in the middle.
Careful.
Green, blue. No.
Careful.
Not so dark.
It's
Notice this down here.
Wait, hold up.
That's nanometers. Is that frequency or wavelength?
One of the two.
You're dealing with wavelength. So you can't go from here to there.
So it's red.
you can't do it. Can't solve
You
it.
can solve it. Because you now have frequency.
It's STV.
So you can't use.
Watch the video, close your eyes.
So what's the answer?
Clear.
So you can't use wavelength to do it.
No, you need to use wavelength. That's what I'm telling
So
you.
you can't use
But
frequency to use it.
you can't get solid in there. Because if you go to visible light, I'm going to ask you to give me the color.
Red.
How do you do
I'm gonna
that?
use frequency.
Okay, you're saying red. So in this case, you're just taking a shot in the dark.
No, I'm gonna say green.
So you're saying green.
It's definitely red.
I say like in between the orange.
If I'm guessing, where I'm going to say we're somewhere
Red orange.
in green or the yellow.
I said yellow too.
Really?
Oh, surprise.
But you're just guessing.
Yes.
You're just guessing.
Well, it don't
Me
count.
just
You
guessing
already
is
know
pretty
the
close.
answer.
I don't. I literally just created this problem out of my head.
Alright, then let's go.
So in this, you've now solved for this. So now you can move on to find the wavelength because you now have frequency. And what links the two together? Frequency. So in this, we can look and say speed of light, wavelength times frequency, but I need wavelength. How do I get wavelength by itself? We're multiplying here. You divide both sides by frequency,
Which one's wavelength?
lambda. So wavelength is equal to the speed of light divided by frequency. So now we come in here, we figure this one out. Speed of light, 2.98 times 10 to the 8 meters per second divided by 5.5086 times 10
Where did
to
you
the
get
14th hertz.
Alright, can we back up a
Okay.
second?
So why are we getting
Where
hurt?
did you get 2.98?
That's the speed
I
of
got
light.
2.98 from here. It's the constant. It doesn't change.
Okay.
Anybody else lost?
What is that?
Because
I'm good.
everybody was going nuts.
I'm good now. I just didn't know where you used it.
So now in this, we're going to do that in the calculator.
I was good on the first one.
Do. Here comes the fun part.
That's a lot of numbers. That's not a lot, but it's.
All right, before I uncover this number, please understand that I stored this number in my calculator. I didn't put the 5.5086. I took the 5.50860247.5 e to the 14 I stored that in the calculator to give me this.
It's wide.
Whenever I did the math, I did that because it makes my math in the calculator a lot faster. Because then I can just do 2.98 e to the 8 divided by a. Because I store it as a. Thank you.
My calculator got clear.
Like, you didn't just type that in?
And I thought the whole thing was hard.
I got that answer, but I got several zeros in front of it.
I didn't get that number.
What's wrong?
What
So
is it?
what color was it?
This was the answer I got.
Same thing.
Do I just
Look at
type
my exponent. -7.
that?
So
What I do? Well, this is better than the
what it
last
is,
time
it's the
we
same
did.
thing, but it doesn't have it in a scientific notation like I do.
Yeah.
Yours just has it out as an expression.
How did you get that one?
I didn't get the same answer.
I do believe I want to go on.
The bottom number is
Can I go get my stuff from the
How did you get
Yep.
that 5.4?
You can do either one. I can do that.
Okay, here's what I've done.
So the constant in this one is the speed of light, which is 2.
All right, so this is what I'm saying I've done. I don't have that show. I just got to show the screen. All right, if you're watching the video, close your eyes.
I do okay, so I'm not sure.
Open your eyes. I don't know if you can see it on the video or not. I'll talk you through it. 13. All right, so on this, here's what I've done. I did that first problem like what I told you. Right here's that first problem I set up in my calculator. It gave me 5.508602475 e to the 14. But I told you just round 4 places past the decimal. What we did to give us 5.5086 times 10 to the 14th. A lot of you is going to punch that back in the calculator. But instead of me doing it, I just stored my answer from that as A.
How do you do that? What's that?
You don't have to, but I'm telling you this ahead of time because so many of y'all are going to freak out. Just know what I got, Mr. Hall. I got 5.4081.
How do you do that? Just do
This is how you do it. I don't know if it's going to show up good or not.
I got the same answer, but I didn't the other one. Yeah, that's what I did.
All right, this is how you do it. You literally take... What?
Then your card can do it a little bit.
Up. Oh, there you go.
All right, on this is what you're going to do, okay? So on here, you're wanting to store it. So down here, right here's the on button. Right above it, this STO with an arrow is stored. So you hit it, and now it's saying whatever was there, we're going to store it as something. So now you have to go to the alpha key, which is the green key, and then you just choose one of the letters. All the green letters that are going through here. So I'm going to do B. So alpha, hit the abs button because I got the green B right here, and hit enter. That now stores B as that number. So if I type it in something, I can just go like 1 times alpha B. Instead of having to type all that stuff out. I'm going to do 2 times alpha B. So it just saves everything for me.
So cool.
That's what I'm saying I did there so that nobody freaks out on me. All I did is I took,
So bright.
I punched in the light constant, so in parentheses 2.98 e to the 8 in parentheses divided by A because I stored our frequency as A. Okay? Now comes the fun part.
That wasn't the fun part.
That was so.
This whole thing's fun for me. I had a blast. You're not finished. You have wavelength now, so you can do something with it, but take a look at something. This is in nanometers. What are we in? So guess what we have to do?
The prefix.
You gotta do a prefix conversion. So in this case, I'm just gonna do it over here. So 5.4097 times 10 to the something another. So now we gotta find what something another is. So we're starting at meters. So I have to go from meters to nanometers. Meters, that's the base unit, so 0 minus the change in the prefix. What's the prefix? New prefix we're going to. Nano, which is -9.
The last chance for any senior that needs an order from Mr. Sweat to report to the Visual Learning Center.
So subtracting a negative,
Place an order today.
adding a positive,
The Visual Learning Center.
gives you 9. But you're not done, because you have to add to it what you originally started with. Plus -7. Because that's what we got up there. Which equals 2. So 2. So we're dealing with 5.4097 times 10 to the second. If you punch that in the calculator, or you just look and say, what's 10 squared?
100.
100. So 100 times 5.4097 gives you 540.97. Nanometers. Well, it's just taking a while because it's the first time y'all have seen it.
It's gonna take me a while on that quiz too.
No. It's the first time you've seen it, you're all freaking out. That's like remember the first time we did a mole problem like this? It
Wait,
took the whole
so
time.
this is hard.
Oh, it's ridiculous.
Yeah, this is hard.
So what? How
You said
many
it was
that,
fun.
when you get that, is that how many places you move the decimal?
Oh, don't say that. You don't just move this.
I want to go back.
Multiply or divide by factors of 10. You multiplied by 10 twice. Or you look and you say, you multiply by 10 squared, which is 100.
This is better than
Okay, you only pay $100.
So in this, 540.97 nanometers. Now, where's that's going to fall at? We got to choose the color. Notice something.
Green.
Here's 500. Here's 600. You're looking at 540. We're about right in here. It's 550, so about right there. Somewhere in there is about 540.
That's a good guess.
So what color? What color? Ugh, what color? What color?
Green.
What color is our photon?
Green.
Green.
Pineapple green.
Watching video, close your eyes.
Does it matter, like, if it's green and yellow?
Oh, it matters.
So we gotta say green, yellow?
It's green.
But if it was green, yellow?
You put green, yellow. I'll give it. I ain't that big of a nitpick.
It doesn't matter.
Well, I don't know. It's chemistry.
Photon is visible light of the color green. Understand, if you stop here at frequency, you're not right. If you stop here at solving for wavelength, you're not right. Answer the question being asked of you. What type of photon? This photon is visible light. And within that, I'm going to ask you for a color. It just happened this fell in the light spectrum, visible light spectrum. For the color green. Do you have any questions?
Can we see it?
No, that's for tomorrow.
Yes. Alright, I'm going to tell you what I told sweet little Alexis Cunningham. Speak with confidence. Let the inner beast out. Speak, child. Ask your question. It's like you got quiet. I cannot hear you.
It reminds me of
Speak.
We've heard the girls into the first.
like, I don't know. So like,
Okay, we didn't convert it.
yeah.
We solved for it because there's a relationship between these two. Are you talking? You don't understand why I went from joules and joule seconds to hertz?
Well, the S would be on top.
What is it?
Because you said 1 over S, right?
Yeah,
Equal S.
the negative.
Okay, but what if the S is in
And then seconds. This won't be on top.
Okay. I have a question.
Yeah.
Okay, so it's meters per second, and then on the bottom it's hertz. Is that because we're solving to get meters? Like is that wrong?
Yes, because whenever you look at this, what's hertz? Hertz is also equal to inverse seconds. So this is meters per second divided by 1 over seconds. Whenever you're dividing by a fraction, it's the same as multiplying by the reciprocal. So it is meters per second times seconds over 1. Seconds cancel to give you meters.
Okay, that makes a lot more sense.
Yeah, 'cause I even,
I like